Jmath.
Now we get to the last section in probability, and this is the password section or the secret code or whatever they want to call it. So in this, you are going to get certain scenarios. They're going to tell you how many spaces are there in the password, and then they're going to give you restrictions based on which space and whatever. So like in this example, there's a 5-digit code. The first 2 digits must be numbers from 0 to 9, and then the last 3 must be letters from the alphabet. So they are always going to give you a scenario, and then they're going to ask you certain questions about that. Now, it's a very strange section. It's part of fundamental counting principles, the Great 12 probability, but in this case, you never use factorials. And this is some of those questions where even if you didn't study, you can maybe strike it lucky and get full marks for this because you don't really need prior knowledge to do this. On the other hand, this could be one of the most difficult questions in the paper. Watch out for the last question in this video. Yeah, that has caught many people and stolen many distinctions in the past because of how complicated it is. But let's go through this. Firstly, just check the notes. Guys, I'm not trying to troll you or to be sarcastic or anything, but just in the last week, I taught this to about 5 students. 4 of them did not know how many letters there are in the alphabet. So make sure you know these things before your paper, that they don't catch you out on grade 1 theory because you didn't know there's 26 letters in the alphabet. Another thing, if they say use the letters from 0 to 9, there's actually 10 options because 0 is included. You know what an even number is, you know what an odd number is. Let's see how to do these questions. So, like I said, a 5-digit password. When I see this, I am going to make 5 lines just so my brain can see, okay, where am I looking at? And then these are from 0 to 9, okay, dot, 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 9, all the way from 0 to 9. And then the last 3 are from A to Z. Okay, so now I must just read the questions. Can stuff repeat? Are there restrictions or what's going on? Question 1, how many passwords are possible if repetition is allowed? So like I said, if I have all the options from 0 to 9, there is actually 10 possibilities. It can be repeated, so there's 10 possibilities. Alphabet, 26, 26, 26. Okay, guys, so it is as easy as that if you remembered how many options you are working with. So to answer the question, I am just going to put multiplies in between them and then type it on my calculator to see. So for question 1, it would just be 1,757,600. So over 1 million different options if that is the restrictions on this password. Question 2, how many passwords are now possible if repetition is not allowed? Okay, so the same setup, but whatever I choose for the first position is not available for the second position. So then this changes to a 9. The same with the alphabet spots, starts with 26, then 25, then 24. And once again, fundamental counting principle, I now just multiply the amount of options I have in each space. If I type that in my calculator, the answer now goes down a little bit to 1,404,000 options for this password. Question 3, how many passwords are possible if repetition is not allowed and only even numbers and vowels may be used? Okay, so now I must just think clearly. What is allowed in each space? So only even numbers, so 0, 2, 4, 6, and 8. And then the same with this one, 0, 2, 4, 6, 8. Then with the other one, only vowels. Okay, guys, so back to grade 1 and 2, the vowels are listed there. So I know you're a matric, I know many of you know this, but there are many students who forgot completely what a vowel is. So this just gives me 5 options, so A, E, I, O, U. Yeah, so let's write down if repetition is not allowed. So for the first space, I have 5 options. If I used one of those options, I only have 4 options left in the second space. The same with the other one. I have 5 vowels, then 4, then 3. So the answer to this one, if I multiply, would actually just be 1,200 different variations, if it may not be repeated. Question 4, what is the probability of getting a password that contains exactly 9? Okay, so if we go back in this chapter to the very first video, I told you guys that whenever they tell you what is in a certain space, then I replace the options with a 1. So in this case, I am going to say, but that is going to be a 9. So I'm going to change it to a 1. Okay, now in the second space, this can now not be a 9 anymore because it must have exactly 9. So then that would be 8 different options. Then with the others, because repetition is not allowed, this is just again going to be 26, 25, 24. Okay, so many of you will ask now, but why is the 9 in the first position? Okay, so what I'm going to do is I'm going to work out this answer, and then I'm just going to multiply by 2 to compensate. But what if the 9 is now in the second space and the 8 is in the first space? That would still then give me exactly 9, because in this list, I took away the option for another 9. So it can't be 2 9s next to each other. And therefore, if I just work this out and I double the answer, then I compensate it for if the 9 is in the first space or in the second space. So the answer for question 4 is 249,600 different options that contains exactly 9. Question 5 is also a trick question that you need to get used to, so you can actually prepare for this one. So let's just see. What is the probability of getting a password that contains at least 1K, repetition is allowed. Okay, now if it contains at least 1K, I don't know if it's just 1K or 2Ks or 3Ks. And I don't know in which position the K would be if there is only one. So it's going to be way too long and almost impossible because we said there's almost 1.8 million different options and most of them contain a K. So it's impossible to work out everything that does contain a K. Whenever you see this combination where they say at least one, work out exactly the opposite. So let's say this now cannot contain a K. So somewhere in the A to Z, I'm taking away all the Ks. Then this means there's 25 options for my alphabet spaces and still 10 for the numbers. So if I work out that option, that would be all the passwords that does not contain a K. If I know that number, I am just going to subtract it from this number. And that's how I would know how many of them do not contain a K. When I typed that in the calculator, I saw it's 1.56 million that do not contain a K. So therefore, to answer the question, I'm going to say it's every option with the repetition allowed minus the ones that do not contain any K. And it's probability, so I need to divide all of that with my total options. And that would then give me the answer. Okay, guys, sorry, just to backtrack, I see with question 4, I missed the word probability. So it is that answer, but it's also divided by 1,757,600. Okay, but let's get back to question 5. So question 5, in its simplest form, if I round to 2 decimal places, would be 0.11 probability chance of something containing at least 1K. Okay, guys, so this was tricky, but it is something you can prepare for. Just go through these examples, and we're going to do a practice video as well, just to make sure you know what to do when it's exactly 1 and when it's at least 1. So always work out the opposite when they tell you at least, and that's the only way to get the answer. Let's look at the next question. The digits 0, 1, 2, 3, 4, 5 are used to form a 3-digit password. Repetition is allowed. How many passwords are possible? So remember, 0 to 5 is actually 6 possibilities. It can be repeated, so the answer is just 6 cubed, which is equal to 216 different 3-digit passwords are allowed. Question 2, how many passwords will be even numbers smaller than 200? Okay, so you need to see these 3 spaces as the hundreds, tens, and the units column. So in the hundreds column, if something is smaller than 200, it must start with a 0 or a 1. I would write a 2, but it's just equal to 200, so it cannot be above that number. So just hold on to that concept. I'm going to come back to it. So I'm going to say it must start with a 0 or a 1. The units column must now contain an even number, because if any number is even, if it ends on an even number. So this is allowed to be a 0, a 2, a 4, a 6, or an 8. But they limited me and said I cannot go above 5, so I'm going to take away the last 2. That tells me I have 2 options for the hundreds column. I have 3 options for the units column, and the tens column does not matter, so that is a 6. And the answer to this question I get if I multiply those 3 numbers. So that just gives me 36 different options. Complies with their restrictions. But it can be equal to the exact number 200. So I'm actually going to just plus 1 to this answer, okay, to compensate for the number 200, because that can be included. So watch out for that. That's a trick question. So the answer is 37. Question 3, what is the probability, okay, so I know I'm going to divide by 216 whenever I get the answer, of getting a random password greater than 300 and divisible by 5? Okay, so greater than 300, it can start with a 3 or a 4 or a 5. Divisible by 5, now we're going back to grade 7 and 8. Something can be divided by 5 if it ends on a 0 or a 5. Okay, so now I know this is 3 options. This is 2 options. And once again, the tens column does not affect anything, so I can use all my options there. So this answer is 36. But watch out for this whenever they say greater than or equal to. So in this specific setup that I put there, it is possible that this is a 3 and a 0 and a 0. So the number 300 is in the list. But the question said it must be greater than 300. So out of the 36 options, I must subtract one of them because the exact code 300 is not allowed. So the answer would be 35. So in this question, you can see how tricky it gets. Not a math issue, it's an English issue that you need to either include something or exclude something. And you do that by just adding 1 or subtracting 1. It's going to be impossible to limit. This cannot be a 0 if this is a 0 and those things. It's with repetition that is allowed. You just plus 1 and minus 1. But unfortunately, the next question is a lot more complicated. Let's see. The last question. The digits 1, 2, 3, 4, 5, 6 are used to form a 4-digit password. Repetition is not allowed. How many passwords are possible? So if I now look at all the spaces, they did not give me any restrictions. So I have all 6 possibilities. So from 1 to 6 is possible there. So that's 6. Repetition is not allowed. So that's a 5, that's a 4, and that's a 3. Okay, so I can write this as a factorial, So I can say this is 6 factorial. I'm not using 2 of them. But in this case, it's widely accepted that you're just going to multiply. Okay, so it's your choice, but the answer is going to be 360 if you just go with factorial or if you just multiply. Question 2, how many passwords will be numbers smaller than or equal to 3,000? Okay, now we need to think clearly. So if the password must be smaller than 3,000, I can say this needs to be a 1, a 2, or a 3 I'm not going to include. I'm going to just plus 1 at the end if that is allowed, but let's just see if it is allowed. Okay, now we said we have 6 possible options. If I used a 1 or a 2, so I'm going to write 2 possible answers there. Now, I'm only going to pick one of those. So out of the 6 possibilities, either the 1 or the 2 will not be possible for the second space. So I'm going to write a 5 there. Now, I'm going to use one more, and I'm going to use one more. So that would be the answer for that question. Let me just write it out. So 1, 2, 3, 4, 5, 6. So let's just go through one scenario so you can see why I'm doing the numbers that I'm doing. Let's say I'm choosing a 1 for the first space. That means 1 is not allowed in the second column, and that's why I'm not writing as 6 options that I can multiply for the second space, only 5 options. But now, let's say in this case I'm choosing a 4 for the second spot. Now I can't use a 1 and I cannot use a 4, so therefore there's only 4 different spaces left. Let's say in this one I'm choosing the 2. Then for the last space, I can't use 1, I can't use 2, and I can't use 4. So that's why I only have 3 options for the last space. Okay, guys, I hope this is making sense. It's all about what is all my options and what's left after I chose something. It only gets this complicated when they say repetition is not allowed. So I'm going to say the answer to this question is 2 times 5 times 4 times 3. And if I multiply that, that would just give me 10 times 4 is 40 times 3 is 120 options. So now in the previous question, when we did the equals to 3,000 or not equals or whatever, we had to plus or minus a 1. Now I first need to see, is it possible to get the number 3,000 from my list? And if I look at all the options for each space, there's no zeros included. So the option 3,000 is not there. That's why I do not need to plus or minus 1, because it doesn't matter how hard I try, I'm never going to be able to form a password 3,000. Question 3, what is the probability of getting a random even numbered password greater than 3,000? Now, this is the most difficult password question that they can ask. Maybe it doesn't look that way, but if you need to now think and compensate for everything, that if I choose a 6 there, I cannot choose a 6 there, but what if I choose a 2 there, then I also need to not choose a 2 there or there, and it's just almost impossible. So let me show you a possible way to do this. There might be others, but this is the one that I found as the easiest. So the only way to make absolutely sure that nothing repeats is to do 3 separate scenarios. How do I know it's 3 separate scenarios? Because they said it must be an even numbered password. That means in the last space, this can be either a 2 or a 4 or a 6. So to make sure there are no duplicates, I'm going to say this first block ends with a 2. The second one ends with a 4. The third one ends with a 6. Now, because I'm setting 3 different scenarios, I must plus each one separately. Okay, now, if I make sure that the last one is a 2, then I cannot use a 2 in the other spaces. In this one, I cannot use a 4, and in this one, I cannot use 6s there. Okay, now what about the first space? They say it must be a number greater than 3,000. So in this case, this could be a 3, a 4, a 5, or a 6. Okay, so there I made sure that it cannot be a 2 in the first space. Now with the middle one that ends on a 4, I can say this could be a 3, it cannot be 4, it could be 5, or it could be 6. And then the last one, this can be 3, 4, or 5, but it cannot be a 6. Okay, let's see how we would write that. So I know that I said the last space would be occupied by a 2. So I can put a 1 there. Remember that the things I write on top of the line is the amount of options I have for that space. So I only have one option because I said it's a 2. Now I'm going to this first one. From there, I know that it cannot include a 2, so I have 4 options there. If I'd now chosen the last space, and I've chosen the first space, then for the third space, I don't have 5 options because I've already placed 2 numbers up top, so I have 4 possible options. So let's say I chose a 3 there, I cannot choose a 3 again, and that's why I'm making it 1 less than I actually wrote down. Okay, if I now chose the second space as well, I'm only left with 3 possibilities. So let's say I cannot do the 3 there, I'm choosing the 1, then the 1 and the 3 is not an option anymore, and I only have 3 options left to choose from in the third space. Let's do the other 2. So 4 is just 1 option. Now I go back to the first space, there's only 3 options. I now placed 2 of my options there, so this would then be a 4, and this would be a 3 as well. For the last one, this is 1, this is 3, then this would be 4, and this would be 3 possibilities left. Okay, guys, now I'm just going to multiply each one of these three parts, add them together, and that would then be the answer. But it says probability, so I know I'm going to divide by 360. So when I added, I got 120. The question said, what's the probability that this would happen? So I'm just going to say it's 120 divided by 360, and therefore the probability is a third to get this specific scenario. There we go, guys. That was the whole playlist for probability, or the fundamental counting principles of grade 12. Please go through all the practice videos to make sure you have a hang of this, and then we can start doing exam questions. Good luck with this, guys.
If this video helped you, please like and subscribe.
Jmath.